Hello everyone. Today we shall talk about the topic grouting procedures. Whenever you talk about the grouting procedures, we have to know which materials are required to be grouted. That is, depending upon the material to be grouted, whether we have to grout rock or natural soil or filling, and the purpose of grouting. For what purpose we have to do the grouting work, that is for seepage control or for the strength of stabilization. A well-planned procedures has to be adopted to achieve the desired results. Here I would like to tell you, whenever we talk about grouting procedures, it consists of 5 components. The grouting procedures consist of 5 components. The first one is pre-grouting site investigations, grout hole pattern, grout characteristics, grouting plant and equipment, injection methods, grout injection measurements and monitorings. So these 6 components we have to study under the heading grouting procedures. So today we shall talk about these 4 components. The remaining 2 components we shall discuss in the next lectures. So let us begin the first point, which is called a pre-grouting site investigation. That means before grouting, we have to go for the site investigations. That's why it is written here to decide the method of grouting, which method we have to follow at the site, and extent of grouting, up to what level, up to what depth we have to go for the grouting. It is required to conduct site investigation before commencing grout operations. The investigations includes geological survey and investigation drilling. Geological survey consists of studying the geology of the area where we have to go for the grouting with the help of mapping method and exploratory drilling. That means we have to go for the exploration to establish the fissures, fault, folds, zones of weakness, deep strike. So we have to know that at our site whether the fissures, fault, folds, and zones of weakness are available. That means we have to know the location of the groutings, where we have to go for the grouting. What is the at the place where we have to go for the grouting? We have to know the type of soil, the type of fissures, faults, folds. Geological study we have to carry out first. And next is the detailed explorations are carried out by drilling boreholes and collecting samples for laboratory test to determine shear strength, grain size analysis, permeability for the location where grouting has to be carried out. You see, as I told you, that whether we have to go for the grouting either for seepage control or to increase the strength of the soil. So depending upon these requirements, we have to go for the detailed explorations. That means we have to make a boreholes, collect the soil samples before grouting. What is the shear strength, particle size analysis, permeability also we have to know. See, whenever you talk about the permeability, whether we have to make the soil impermeable to control the seepage, or even permeability also gives the idea that whether the soil is cohesionless or cohesive. That also idea we can get by the permeability test. So these parameters comes under the site investigations, which we have to carry out before grouting. In addition to this, a field permeability test is must to facilitate precise estimation of the required pumping pressures, grouting pattern, and type of grout. So these 3 things, field permeability test, as you know, pumping in test, pumping out test. So depending upon the test, once we go for the test or once we find out the permeability in the field, accordingly we can decide what should be the pumping pressure, what should be the grouting pattern, and what should be the type of grout which can be used at a particular site. Next, components of the grouting procedures is grout hole pattern. See, grout hole patterns, grouting may be shallow depth with low pressures. Definitely, if we are going to carry out the grouting at shallow depth, in that case, more pressure is not required. Whereas in case of deeper depth, we have to go for the high pressures. Thus, here what it says that the shallow grouting is done first to seal all major crevices. Shallow grouting, that is the up to the limited depth from the ground surface, we have to seal all the major crevices, and then deep grouting can be undertaken, or we can go for the deep grouting later on. First we have to go for the shallow grouting, right? Then we can go for the deep grouting. The field permeability logs helps in deciding the zone to be grouted. See, permeability also gives based on the permeability also we can decide below the ground level which areas are required to be grouted, the type of grout to be used, and the possible extent of grout penetration under a given pressures. So permeability also gives a good idea. So under the heading grout hole pattern, ideally the spacing of grout holes should follow a grid patterns such that the radius of penetration is sufficient to cause slight overlapping between the adjacent holes. Whenever we are going to for the groutings, in that case we have to make a holes in such a way so that after the grouting the grout should overlap to each other, right? Slight overlapping should be there. A second and subsequent half size grid is then injected to fill the spaces between the adjacent grout. So whatever the space, this is the primary holes, and whatever the spaces are going to going to remain in between these two holes, that is called as secondary holes, which can also be grouted later on. So sometimes a third and quarter size grid is also required to achieve the target. That means this grout hole patterns, what it says that we by the grouting we have to cover the whole area. That's why we have to go for the first primary holes, then secondary holes, even third and quarter size hole is maybe also required. So under the heading grout hole patterns, as the preliminary guidance, the spacing of grout holes may be used as per the table given below. You see the importance of permeabilities. If the permeability is greater than 1, then grid spacing we can go for 6. That is the fissured rock. You can see we are putting more spacing because permeability is high, millimeter per second. Right? High permeability, we can go for the more spacing for the grouting purpose. In case of 1 to 1 into 10 power minus 1, the grid spacing will be 3 for the soil, medium, coarse sands and gravels. Whereas if the permeability is more than 10 power minus 1 millimeter per second, in that case the grid spacing will be 0.5 to 1 meter, which will be the fine sand. So spacing is going to be reduced when the size of the particles is less. That means the permeability will be less. More size of the particles, more permeable. As you know, in case of coarse grain soil and fine grain soil, right? Fine grain soils have the high permeability, whereas coarse grain soil, the coarse grain soil has high permeability, and the fine grain soil has the less permeability, right? So under the grout hole patterns, grout holes are vertical, but sometimes inclined holes are made to meet some objectives. Inclined holes made to ensure maximum number of joints, bedding planes are intersected by a specific length of the grout hole and beneath building foundations. See, inclined holes we are going to cover. We are going to make inclined holes for the grouting so that we can cover as maximum possible area. Maximum area can be covered for the grouting. Oblique holes, that is the inclined holes, are usually made with an angle not exceeding 15 degrees to the vertical. Grout holes are drilled with rotary drilling or percussion drilling. The next component is grout characteristics. See, in order to obtain the desired effects, a grout should not set quickly because this may affect pumping, but should set and harden after completion of the pump. We have to select the grout materials or grouting materials in such a way it should not quick set it should not set quickly. Otherwise, we cannot go up to the we cannot complete the complete grouting work cannot be done, right? It may hinder the create the hindrance for the pumping. That's why it's written here, not set quickly because this may affect the pumping. The, we cannot go at the deeper depth, but should set harden after the completion. Once we complete the our required depth of the grouting, then only the hardening should start, right? So grout characteristics should be like that. The fluid viscosity gradually changes with time as chemical reaction takes place to transform the grout from liquid stage into a gel stage or semi-solid stage. Some grouts react in minutes, while some may take 24 hours time, depending upon the chemical reactions. The principles to follow in choosing the grout. Whenever we are going to choose the grout, what factors we should consider? What should be the properties of the grout? The first property is the grout must be able to penetrate the voids of the mass to be injected. The grout should be resistant to chemical attack. That means it should not be chemical attacks should not be there once you are going for the grouting. It should penetrate easily, right? The grout should be able to develop sufficient shear strength. So while choosing the grout, we have to consider these parameters, or we can say the grout should have these characteristics, all these three characteristics. The next, under the heading grouting characteristics itself, recommendation of various grout types for application in different situations are presented below. We can see here, as we know, we have already studied in the previous lecture, the different types of grouting materials are there: suspension grouts, emulsion grouts, solution grouts. So you can see under the heading the suspension grout, PFA, pulverized fly ash, cement, clay cement, and where it is applied, PFA, pulverized fly ash, mass filling in very coarse soil and rock fissures, cement, mass filling in very coarse soils and rock fissures, plus ground strengthening, right? Ground strengthening can also be achieved by the cement grout. Clays as a suspension grout, mass filling in medium coarse soils, and impermeability improvement. Once you are going to use the clay as a grouting materials, it can make the soil impermeable. Clay cement, similar to clay but added strength, because cement we are going to put here, that's why strength is also going to increase. So this comes under the suspension grouts. Emulsion grouts, it improves the impermeability. Solution one sort, solution two sort. One sort means all the chemical solution grout means the chemical grouts. As we know, one sort we have already discussed that two chemicals are mixed together and then it is grouted at a particular locations inside the ground. Whereas in case of two sorts, first we have to inject the first chemical solution, and then after that we can go for the injection of the second solution. So where it can use permeability and strength improvement in medium coarse soils. Two sorts, as for one sort with additional control of gel time, also suitable in fine soil. Next we can see the fourth one is called as grouting plant and equipment. You can see this figure, grouting plant. This here water supply is there, water meter for measuring water to the mixture. This is the grout mixture, and this water is coming here in this tank, and from here it goes to the agitator in batches, or grout discharge from mixer to agitator. You can see here agitator is there. From agitator you can see different lines are there, different pipelines are there. One we shall discuss in details in the all the slides, next slides also. So here once it is agitated, then grout is taken by this pump, and pump supply the grouting materials to the grout hole for injection purpose or for grouting purpose. You can see here different valves are also there. Pressure gauge at pump, bypass line is there, return selection of circulation line. Okay, these valves control the quantity of grout fed into the circulation line. So this is the circulation line. From here the grout is coming, and it is going to be injected into the grout hole for grouting purpose. So you can see the another pipeline is also there. If refusal is there, that means if the extra quantity the grout is going to occur, that means the hole is not going to take the some more grout materials. In that case, it is going to pass through this line. That is called return to agitator. Grout not taken by the hole. That comes to the again. It comes back to the agitator. So let us read this text part. Both suspension and solution grouts use the same mixing plant and delivery system, and they differ mainly in their storage, because suspension grouts and solution grouts, definitely it will differ in a storage functions and mixing configurations. A grouting plant includes a mixer, an agitator, agitator, pump, and piping connected to the grout. These pipelines are there. A typical cement suspension grouting plant is shown in this figure. Two systems like single line type and circulation type piping are shown in the figure. We can see here in the circulation line, the unused grout is returned to the agitator, and single line type the grout refuse is wasted. You can see if this pipeline is not there, that means if this is called a circulation line. So whatever the grouting material is going to come through this pump by the pump, right? From this line, you can see this pipeline. Through this, the grout is coming into the hole, or it is injected. Okay, if refusal is there and this circulation line is not there, in that case what is going to happen? In that is called a single line. Single line means this line is not there, this circulation line, that means return to agitator line is not there. In that case it will be wasted. Okay, so circulation line means all the facility will be there. Whatever the extra grout is going to be going to remain in this, or going to be come out from this hole, will return back to the agitator. That means it will not be wasted. For solution grouts, separate ingredients are stored in a stationary tank and metered out on flow or volume basis. They are mixed at junction points and delivery to the intended grout pipe. The grout pipes are connected in a manifold system, but each is separately valved so that complete control is obtained over the flow. This is about the solution grouts. You can see the basic items required for a grouting plant. This is the grouting plant. Okay, this is the layout of the grouting plant. Also, we can say measuring tank to control the volume of grout injected, mixer to mix the grout ingredients, agitator to keep the solid particle in suspension until pumped, not required for chemical solution grouts. for chemical grouting or solution grout, it is not required. Agitator is not required because it is already in the solution form. Pump is also required to draw the grout from the agitator. Here you can see the pump is there. It is drawing the grout from this agitator to deliver the pumping line. This is the pumping line. Okay. The different valves are also there. You can see. Sometimes this grout hole is not ready, and we are withdrawing the grout from this agitator. So in that case, if the grout hole is not ready, in that case, what we shall do? We shall open this valve, and again, we can use the bypass line and send it to the agitator. Control fitting to control the injection rate and pressure so that the hole can be regularly blended with water and the thin grout. Control fittings that it controls the injection rate and the pressures. So see, in mixing machine, mixing is done in 3 stages. What are the stages? The first stage, what we have to do, formation of vortex which acts as a centrifugal separator. Once in the first case, vortex motion is generated. That means the thickened grouts and unmixed cement are pushed to the periphery of the vortex and passed to a mixing rotor. Okay. Next stage, the treatment of thicker fraction and unmixed cement from the vortex. So first we have to form the vortex motion, right? Which vortex means it acts as a centrifugal force is there. Vortex is also called as whirling motion or the spinning motion. Okay. So first we have to create the vortex motions, right? Then treatment of thicker fractions and unmixed cement from the vortex. In this case, these are subjected to the violent shearing action in a mixture rotor, which break up thicker fraction and lumps of cement and wets and produces a grout resembling like a colloidal solution. That type of colloidal solution like grouting materials are going to be produced rather than a mechanical suspension. So the thicker materials are going to be broken, okay, in the mixture rotor. So this is the second stage, and third stage in mixing is circulation of the treated fraction back into the vortex. Vortex continue to spin till all the thickened fraction of cement lumps are broken and entire grout reaches a uniform consistency. So these are the 3 stages of the mixing. You can see the different types of mixers are there. So the first one is barrel type mixture. A barrel type mixture consists of a cylindrical drum. You can see this is a cylindrical drum. So vertical and horizontal barrel. This is the vertical barrel. This one is the horizontal barrel. Placed either horizontal or vertical with an axial shaft. These are the shaft. These are the shaft connected with the pedals or the blades. Cement and water are thoroughly mixed with the help of pedals. You can see cement is going to be put from this hole and water is also coming from this line. So both are mixed together in this tank, cylindrical tank, and then it is delivered. In the case of a vertical barrel type mixture, in case of horizontal type mixtures, we can say water supply is also there, cement is also coming in this tank, in this cylindrical drum, and it is mixed thoroughly. So vertical type is used to handle a small quantity of grout. Okay. So next one is the grout agitator. A grout mix should be continuously agitated to prevent setting. The grout agitator should continuously operate. Otherwise, the grout will not be uniform solution, uniform suspension, right? So it should be properly agitated. So target is it should not sit. This is achieved by the agitator sum between the mixture and the grout pump. So in between these two, this a sump is there in which the agitation takes place. Agitator sump is a tank which has an agitating mechanism consisting of vertical shaft. Two, the horizontal blades are connected and revolve 30 to 100 rpm, right? So this is the agitator. You can see here the discharge of circulation line is coming here, right? We can also say the discharge is coming from the as a refusal once the hole is fully grouted, and whatever the extra grout is going to come out from the hole, that comes through the recirculation line, and finally it comes in the agitator, so that again it is reused. Next we can say in the grout agitator, the grout mixed from the mixture is passed through a wire screen to remove pieces of stacks, springs, and other foreign matters. When the from the mixer machine, the grouting materials comes from the mixer to the agitator. What happens? This you can see here also a screen is there, so that all these slag strings and other foreign matters will be screened. It will not go inside the this this agitator. Okay, and here also this whenever it is finally it is going to be supplied taken by the pump. So here also the screen is there, so that the unwanted things will not go to the pump. Also another screen is written here is fixed to the agitator near the delivery pipe. This delivery pipe is here to prevent the entry of lumps to the pump. So what we can say, two screens are there, one at this location, so that the foreign matters will not go into the agitator, and another screen is put at the delivery point, so that the pump will not get the any type of lump material, waste materials. Otherwise pumping will be disturbed. Pump may feel disturbance in operation. A graduated deep stick is used to measure the quantity of grout to the agitator. A deep stick we can use to measure the quantity of the grout materials inside the agitator. So the next point is the pump. Pump should be able to provide. We have to also use the pump in a grouting equipment, grouting plant. Pump should be able to provide measures pressures of 2800 kilonewton per meter square. Pump may be piston or diaphragm type. The following capacity may be preferred depending upon the type of grout. So types of pumps: a small pump, large pump. Pressure 0.8 Newton per millimeter square, 1.5 millimeter square. If you are going to use a small pump of having the pressure 0.8 Newton per millimeter square, in that case it can deliver the grouting materials 120 liter per minute. Similarly, for 1.5 pressure, the delivery is the 45 liter per minute. For large pump, you can see if the pressure is 3.5 Newton per millimeter square, in that case delivery amount or grouting materials will be 450 liter per minute. If the pressure is 10 Newton per millimeter square, then the delivery will be 130 liter per minute. So other accessories needed for the grouting plant are the grout pipes, hoses, valves, nipples, pressure gauges, packers, casing tubes, flow meters, etc. So what I'd like to say here, the four components of the grouting procedures just now we completed. In the next lecture, the remaining two components, that is the injection methods and the grouting injection measurements and monitoring, we can discuss. We shall study these two components in the next lectures. So thank you.